All right, so I'm back. For me, it's been like a whole 3 seconds. I need a drink because I've been talking a lot. So what we had done so far in section 6.2 is we had done example 1 and 2. So I want to look at example 3 and maybe example 4. It's just a word problem. So I may talk through it. I don't think I'll do it in depth, but example 3 on page 325. It says find the absolute maximum and the absolute minimum. So it wants us to find the absolute max, not a local max or minimum, but an absolute maximum or minimum. And the absolute minimum wants us to find those for f at x is 2x to the 4th minus 4x squared plus 4. But then it gives us something that it hasn't given us before. It says x, I'm going to put it up here, x belongs to 2 to 0.5. So that's interval notation. So what they're saying is that graph is going to start at, -2. That graph is going to start at -2 and it's going to end at 0.5. So this graph has a beginning and an end. So the first thing I would do, because I'm like this, is I know I'm going to need points. So if the graph begins when x is -2, if x is -2, I'm actually going to figure out what my y value would be. I'm going to figure out what that point would be where it starts at. So if I do that, if I take -2 and I put it into here, -2 to the 4th times 2 minus 4 times -2 squared plus 4. If I put that in there, I end up with 20. So if I were graphing this, which they didn't actually ask me to do, but I'm going to just for some of you who are visual like I am, at -2, this graph is at 20. So let's say that's 10, that's 20, just because I don't have a lot of space. Okay, so there's 10, there's 20, here's -1, -2. So -2 and 20, okay? That's the beginning of the graph. The graph ends when x is 0.5. So again, I would start this off by figuring out what the y value for that is. So I'd actually put that into here. 0.5 to the 4th times 2 minus 4 times 0.5 squared plus 4. Turns out it is 3.125. So if I go over half a square, I go up 3.125, which isn't going to be very high based on my graph because that's 10. So it's going to be like right here. Okay? So that might be the absolute highest the graph goes. I'm not sure. That might be the absolute lowest that the graph goes. I'm not sure. Because I don't know, does the graph go way up here and then come back down? Does the graph go way down here and then come back down? I'm not sure what it does. So that's why I need those critical numbers. So now I'm going to find the derivative, which is going to be 8x cubed minus 8x, and that's it. So I'm going to make it equal to 0. 8x cubed minus 8x. A lot of people get stumped here. Don't get stumped. It's not that rough. I can take 8x out as a common factor, and I would have x squared minus 1. And then x squared minus 1 is a difference of squares, so that's x plus 1 and x minus 1. So either the 8x portion is equal to 0, which means x is 0, or x plus 1 is equal to 0, so x is -1, which it could be because that falls in here, or x minus 1 is 0, which means x is +1. But I can ignore that because it says this graph stops at a half. It doesn't go all the way to 1. So I don't even have to pay attention to that. So I have two numbers, 0 and -1. Sorry, so let me fix that. -1 and 0. All right. Now I need to pick a number before -1. And really, I've already done a number before -1. I did -2 and it came out, oh wait, I didn't put that into the derivative. I got to put it into the derivative. So if I take -2 and I put it into the derivative, -2 cubed is -8 times 8 is -64, and 8 times -2 is -16, but there's a negative there, so that'd be +16. So -64 plus 16 is a negative, which means the graph is decreasing. So then I need to pick a number between -1 and 0. Unfortunately, that means I'm going to have to pick a decimal or a fraction. And I'm going to pick -0.5, and I'm going to put that back into the derivative. So if I do -0.5 cubed, -0.5 cubed times 8 minus 8 times -0.5, I get a negative number. So it's still decreasing. So this is not a local maximum or a local minimum. It's not changing direction. It's continuing to go down at that point. So now I'm going to pick a number after 0. I'm going to pick 0.5 because the graph stops after that. So I'm going to pick 0.5 back into the derivative. So 0.5 cubed times 8 minus 8 times 0.5 still gives me a negative number, okay? Which means, actually it shows that it goes back up, which means that this is negative. So hold on, because I might have made a mistake somewhere. Let me see. It says that -1, it says that -1 should be. So I might have screwed that up. If I do -0.5, let me do that again. I might have screwed that up. If I do -0.5, I think I might have messed up this middle one. Sorry. If I do -0.5, -0.5 cubed times 8 minus 8 times -0.5. Oh, look at that, I screwed that up. Sorry. This one is positive, which means it actually is increasing. So I actually have a minimum here and a maximum here. But are they absolutes? Not sure. So on top of these points, I also need to figure out what value is it at -1. So I need a y value. So -1 to the 4th is 1 times 2 is 2. That'd be -4, which would be -2, plus 4, which would be +2. So at -1, it's at 2, which is like even lower than this one because that was 3.125. And then at 0, it would end up being at 4. So at 0, it would end up being at 4. So this graph basically does that little thing there. So my absolute maximum is up here at -2 and 20. That's the absolute highest that it goes. Now the absolute lowest that it goes is not 3.125 because there's a lower number here, 2. 2 is lower than 3.125. So the absolute minimum is -1 and 2. So to recap quickly, exactly the same as before. You find the derivative, you make it equal to 0, you make your little table, you figure out where it's increasing and decreasing. Once you figure out where the max and mins are, local max and mins are, you find the y value. The only thing is, if it gives you a start point for the graph and an end point for the graph, you have to find the y values for those as well to know where your maximums and your minimums happen. All right. Example number 4. I'm just going to do the highlights of this one, I think. I'm not going to do major in depth. Okay? So, it says the pH in a person's mouth T minutes after eating candy can be modeled by this absolutely horrible equation, which is P is negative 0.0, I can't even tell how many zeros that is, that's 3 zeros, 0.0002 T cubed plus 0.014 T squared, icky, minus 0.24 T, and plus 6.22. And again, they tell you that T, your unknown, is between 0 minutes and 30 minutes, because at the end of 30 minutes, that candy's probably no longer in your mouth. You've probably eaten it. So it says determine the time when the pH is the lowest in your mouth. In other words, when is it most acidic? So, again, I would start by finding the x and y value for the start time and the end time. So at 0 and at 30. And I would put that back into here and get my values. Turns out that at 0, it's 6.22. And at 30, it's also 6.22. So before the candy is in your mouth, the pH level, the acidity level in your mouth is 6.22. So a little bit acidic because 7 is neutral. And at 30 minutes, it's 6.22 again. But what happens in between time? Where is it at its lowest pH? Maybe this is the lowest pH and that candy is going to make the pH level in your mouth have a higher pH number, which would mean it would be more basic. Or maybe it's going to go the other way. So here's what we need to do. We need to find the derivative. So if we find the derivative, we're going to bring this down. It'd be negative 0.0006 T squared plus 0.028, yeah, 0.028 T minus 0.24. Now here's the ugliness with this, which is why I'm not going to sit and do it, and I would never give you something this horrible on a test. In order to make this equal to 0, notice we have a trinomial, T squared, T, and a constant. So this is your A, this is your B, this is your C. You're going to do the quadratic formula with it. Negative B plus or minus the square root of B squared minus 4AC all over 2A. Turns out when you do that, you get 11.31, or, because you always get two answers, right? Because you're going to have negative 0.28 plus the square root and negative 0.028 minus the square root. So it's 11.31 or 35.35. But 35 is above the time limit, so we don't do that one. So 11.31 is where we go. So we pick a number before 11.31. Now I'm not crazy, so I'm going to pick something easy. I'm going to pick 0. If I put 0 in to my derivative, I get 0 plus 0 minus 0.24. So it's a negative, so it's going down. If I pick a number bigger than 11.31, but still under the 30 minutes, If I pick like 20 and I put it in here, so 20 squared times this plus 0.028 times 20 minus 0.24, turns out I get a positive answer. Again, I'm not going to sit and do that, which means it's increasing. So I have a minimum when my x value is 11, or my t value is 11.31. So I'm going to put that back into here to figure out the p, not back into the derivative, back into here. And again, I'm not going to bother to do that. Turns out it's 5.01. That is lower than these two numbers. So 11.3 minutes after you put that candy in your mouth, your pH is the lowest it goes at 5.01. Again, I wouldn't give you one that nasty on a test, maybe on an assignment because you can look back, but and you have all the time in the world, but certainly not on a test. I will give you a few more questions to try. If you were struggling with the homework, you might want to look back at that. Hopefully I've cleared up any questions that you had. If not, make sure that you're asking them. I can always do another video where we can chat via video chat or something. We'll figure it out. So I'll talk to you again soon.